Welcome to the DIY Honda Garage channel. The DTC B1775 indicates a microphone input-output issue specifically characterized as being shorted to power or open. This code is relevant for the 2011 to 2017 Honda Odyssey models that do not possess a navigation or touchscreen feature. The issue primarily involves the HandsFreeLink (HFL) system, which is crucial for hands-free phone operations, Bluetooth connectivity, and voice command functionalities. The absence of proper power flow between the HFL control unit and the front HFL ANC microphone can disrupt communication and lead to audio problems. Hence, understanding how these components interact within the vehicle is essential for effective troubleshooting and repair. Proper diagnosis begins with confirming battery health and ensuring good connections to avoid misdiagnosis. The error B1775 is principally associated with the HandsFreeLink HFL system in the 2011 to 2017 Honda Odyssey. The HFL system allows for wireless communication between the vehicle and mobile devices, facilitating hands-free calls and voice commands. In this context, the front HFL ANC microphone plays a vital role, being the primary interface for audio input during hands-free interactions. The microphone is typically located near the vehicle's ceiling, often in the overhead console area. This strategic placement enhances the microphone's ability to capture voice commands clearly, minimizing background noise. Thus, any disruption in the electrical or structural connection can significantly impact the functionality of the system, resulting in the trigger of error code B1775. The possible causes of DTC B1775 have some common electrical faults that require careful investigation. A short status in the wiring could indicate that there is an unintended connection, possibly due to wear or insulation damage. Loose or corroded connectors can disrupt the signal flow and may lead to intermittent failures, affecting the microphone's operational efficiency. In some cases, the issue may stem from defective components within the HandsFreeLink control unit itself. Identifying these causes is essential to restore proper functionality and avoid recurrent problems. Therefore, thorough inspection and tests should be conducted for each factor influencing the microphone's operation and connection. The symptoms associated with DTC B1775 can be quite evident and affect user experience. One of the most noticeable symptoms could be the failure of voice commands that are not recognized by the system. If the microphone is shorted or open, users may also notice a significant decrease in audio clarity during calls, making conversations frustrating. In some cases, the microphone may appear entirely non-functional, leaving users unable to utilize their hands-free capabilities. These symptoms ultimately hamper the full enjoyment and usability of the vehicle's audio and communication systems, making timely diagnosis and repair critical. Awareness of these symptoms can aid technicians in quickly focusing their diagnostic efforts. The first step in troubleshooting DTC B1775 involves checking for any existing DTCs from the HandsFreeLink system. It is essential to perform this initial check as it provides insight into the overall health of the system. If DTC B1775 is indicated, this confirms that there is a specific issue requiring attention. Conversely, if this DTC is not present, it suggests an intermittent failure or that the system is operating correctly at the time. Proper documentation of DTCs is crucial, as it helps gauge which components may be failing or require further examination. Clear understanding at this stage lays the foundation for an organized troubleshooting approach moving forward. In the second step, the ignition switch must be turned to the lock 0 position, or if equipped, the engine start-stop button should be pressed to select the off mode. This step is crucial for ensuring safety while disconnecting any electrical connections within the vehicle. It prevents any inadvertent electrical discharge that could lead to further complications or harm during the diagnosis process. Taking this precaution is vital for maintaining both the integrity of the vehicle systems and the safety of the technician. Once this step is realized, the pathway is cleared for further diagnostics and component testing in the subsequent steps. Step 3 focuses on disconnecting the front HFL ANC microphone from its 8P connector. This step is essential in isolating the microphone from the HFL control unit, allowing for targeted testing free from interference. Intersecting the microphone connection is part of a procedural methodology to accurately diagnose the fault affecting the system without external variables. Ensuring proper access to this connection may require specific tools or adjustments to gain visibility and handle delicate components carefully. By disconnecting the microphone, the technician can prevent any false readings that could arise from a functioning unit interacting with a failed one, fostering a more controlled testing environment. In Step 4, the technician disconnects the HandsFreeLink control unit from its 32P connector. This critical step serves to further isolate the systems being tested, ensuring that the technician is evaluating the microphone's connection independently. It is imperative to exercise caution while performing this disconnection to avoid damaging sensitive components. Maintaining a clean workspace and organized approach can help streamline the diagnostic process. With the HFL control unit safely disconnected, the technician is now set to proceed with voltage measurements in the next steps, providing essential feedback regarding the electrical flow between the connected components. Step 5 requires turning the ignition switch to the on-to position or pressing the engine start-stop button to select the on mode. This step is critical for allowing electrical circuits to become active, permitting the technician to perform necessary voltage measurements. Activation of the electrical system is essential to establish whether the flow of current is functioning as expected between the HFL control unit and the microphone. Observing the parameters presented in this state will guide further conclusions regarding the health of the system. Consequently, understanding and executing this step diligently lays the groundwork for accurate voltage measurements and potential repairs. Step 6 entails measuring the voltage between terminal number 2 of the HandsFreeLink control unit and body ground. This measurement is vital in assessing whether there is sufficient power flowing as required. Should there be any voltage reading, it indicates that a short to power exists in the wires connecting the HFL control unit to the front HFL ANC microphone. This finding would necessitate replacing the affected shielded harness to restore proper functionality. Conversely, if there is no voltage present, further investigation is critical to determine continuity and other potential failures. This measurement serves as a decisive point in determining the next course of action in repairing the vehicle's audio communication system. The final troubleshooting step involves checking for continuity between specified terminals. This includes verifying continuity between terminal number 1 and number 2 of the HandsFreeLink control unit and terminals number 1 and number 2 of the front HFL ANC microphone. This continuity check is crucial as it ensures that there is an unbroken electrical circuit necessary for optimal functionality. If continuity exists, it signifies that the wiring is intact and sheared conductors are not the issue. If continuity is absent, it may indicate a wiring failure that needs immediate attention to resolve the DTC B1775. This process underscores the goal of verifying the routing and integrity of critical wiring to ensure the sound system functions correctly. Final repair verification is an essential concluding step in rectifying DTC B1775. It involves confirming the functionality of the HandsFreeLink system, along with the microphone's operation post-repair. By observing the system's response to voice commands and audio input, the technician ensures the issues are genuinely resolved. Running diagnostics for any recurring DTCs will further validate the success of the repair efforts. If any issues arise after verification, the technician may need to investigate deeper into the connections or system components. This process reinforces the importance of thorough checks following repairs to uphold the quality of service and reliability in the vehicle's operations. Preventive maintenance is crucial for ensuring the long-term reliability of the HandsFreeLink system and microphone in the Honda Odyssey. Regular checks of electrical connections can help to identify looseness or corrosion before they lead to significant failures. Periodic inspections of wiring harnesses will also allow you to catch wear and tear early. In cases where wiring may be routed in such a way that it's susceptible to damage, rerouting may be necessary to mitigate potential issues. Such proactive steps can extend the life of the components and maintain optimal performance. Implementing these practices is a small effort compared to the inconvenience and cost associated with necessary repairs. In summary, DTC B1775 is directly related to the HandsFreeLink system, indicating issues with microphone input-output connections. Recognizing the symptoms can lead to prompt investigations and solutions to audio clarity and functionality issues. By adhering to the structured troubleshooting steps, technicians can isolate and resolve problems efficiently, ensuring optimal performance of the communication systems in the Honda Odyssey. Emphasis on preventive maintenance is essential to safeguard against future occurrences of similar issues. Overall, understanding the nuances of this DTC empowers owners and technicians alike to maintain peak performance in their vehicles. Please like and subscribe to the channel. See you next time.